Okay, so working out force times distance on a fulcrum. Um, so force is measured in newtons, distance is measured in metres. So we need to make sure we get these the same. Now the force is based on the mass, which is measured in kilograms, which you're used to saying is your weight. And the force is what the gravity exerts on this mass. So hence when you go into space they say you're weightless. You still have a mass, but you don't have any gravitational effects on you. And we tend to use 9.81, which is our gravitational effect. So if we went on the moon, this number would be slightly different, be much lower, but we're not. So 9.81 is what we tend to do. So that works out our force. Now this as a formula is basically what we're saying is this and this, so the distance and the force from the fulcrum, from the centre point, will equal the force and distance on this side. So force times distance on the left hand side is equal to force times distance on the right hand side. So this is left hand side, this is right hand side. And if we know these two, we know one of those, then we can do a simple transposition. So remember, transposition, once you get in any formula in this location, it's very easy to transpose because these are multipliers. So to get it any one over to the other side, it becomes a divide. So if we want a distance, then that goes over the other side and becomes a divide. So therefore this would be, this distance is equal to force times distance, which is the left hand side, divided by the force on the right hand side, and that would give you that one there. Okay, so the best way to do this is give it an example. So let's give this a mass of, say, 80 kilograms, and let's give these some distances. So let's say this is 1.2 meters, and we'll say this is 800 millimeters. Okay, so our formula is force times distance on the left hand side is equal to force times distance on the right hand side. So this is effectively our middle point. So basically the question is, how much force do we need to lift this load on the opposite side? So F is the unknown in this case on this side, because we know this distance, we know this distance, and we know what that is. So first thing we want to sort out, let's sort out and find out what the force on this side is. So this force is equal to its mass, which is 80 kilograms, times 9.81, which is the force of gravity on that. And if we do that, so that's 80 times 9.81. Therefore our force is 784.8, and that will be newtons. So now we know that, we can now put these figures in over here, or we can do the rearranging first. So basically we want to find this side, so we want this F, so this D is going to drop over and become a divide. So the F we're trying to find is equal to force times distance divided by the distance from the left hand side. So this becomes 784.8 times, right, and this is in millimetres, so we need to convert it to metres. 0.8 divided by the distance on the opposite side, which already is in metres. So that becomes 784 times 0.8, which is the distance, divided by 1.2. And that comes to 523.2 newtons is what would be required from the opposite side. If we want to convert this back to kilograms, then we divide it by 9.81. So therefore, kilograms equals the newtons, the force, divided by the force of gravity, 9.81, So 523.2 divided by 9.81 53.3 recurring kilograms. Okay, so here's another question. Basically the same again. So we have force times distance, left hand side, force times distance, right hand side. This time we've got 800 newtons. We have 500 millimeters in distance on this side, so this is unknown. And we have 150 kilograms force on here. So what is the distance that would be required to raise this? Okay, so where do we start? Well, we can start with, let's just rearrange the formula because that's nice and simple and we have it laid out. So we want to find that distance, so that force drops down to the other side. So therefore, this distance, the unknown distance, is equal to force times distance on the right hand side divided by the force on the left hand side. Now we've got two different units. Let's get them to both to be forces. So remember this 150, to find the force, is equal to the kilograms multiplied by the force of gravity, 9.81. Don't ever forget that. Sometimes it's given in questions, sometimes it's not. So we need to try and remember. So that's 150 times 9.81. We put that in. So it's 1471.5. And remember, that's newtons. So that's our force on the right hand side. Now we know all that, we can put this information in. So 800 is that force on the bottom, that force is this one over here, and that distance is here. So the force is 1471.5 times, can't use millimetres, we need it in metres, so that is 0.5 divided by that force on that side, so that's 800. So 1471.5 times 0.5 divided by 800. And it comes to 0.919 metres. So 919 millimetres effectively. Okay, so efficiency can be, normally is measured in a percentage, so efficiency is equal to the output of something divided by the input of something, and in order to work out efficiency, these units have to be the same, otherwise you're working out not a lot, to be quite honest. So if we do it just as this as an output over input, what you'll get is a per unit efficiency, which will be a decimal point of something. Okay, so if you got a per unit of 1, it would be 100%. So to turn it into a percentage, we just multiply by 100. So there's our efficiency calculation. The transposition of this is relatively simple, providing we get rid of this first. So if we get this is a multiply, so it becomes a divide. So it would be this number divided by 100. Which takes it to a decimal again, which then makes it a lot easier. For example, so here we have an example. So we have an efficiency of 83.3% recurring. We have an output of 5,000 watts. We don't know what the input is, and obviously it's a percentage, so with that there. So basically we need to rearrange it so we've got this. So the easiest thing to do, personally, what I find is, let's get rid of this first. So if we do 83.3 recurring and we divide that by 100, which is what that would become over there, a divide, this turns it into 0.833 recurring as a per unit, which basically means we get rid of the 100, which now makes life a lot easier, because what we now need to do is rearrange this formula and this as divide, so it goes up there, becomes a multiply, which means that then can come back down here and become a divide, and therefore input equals 5,000 divided by 0.833 recurring. And if we do that into our calculator, so 5,000 divided by 0.8333 recurring comes to 6,000 watts. So if this was a motor, as most motors are, not 100% efficient, you'd need a 6 kilowatt motor to give out a 5 kilowatt amount of power. Okay, so here's a question. A motor draws 8 amps from a 230 volt AC supply, delivering an output power of 1.1 kilowatts. Calculate its efficiency. Well, here's our formula. Efficiency equals output over input multiplied by 100. So we know our output is this, so we can put that into our formula. So that's 1.1 kilowatts divided by, right, we don't know the input power straight away, so but what we do know is the voltage and the current. The fact it's AC is irrelevant, so power is 230 times 8, so V times I. Okay, we just need to make sure this is in kilowatts, so let's just do that as a calculation. That's 1,840, so that's 1.1 divided by 1.84, if we're going to keep it as kilowatts, times by 100, and this will give us our efficiency. 1.1 divided by 1.84 times 100. So that gives us an efficiency of 59.78%. Okay, so here's a question. An electric motor drives a pump which lifts 800 litres of water each minute to a tank 30 metres above the ground. What power must the motor provide if the pump is only 60% efficient? So what we need to remember is, from our notes, work done is equal to force times distance. And what we do know is that the force from earlier on has to be based on the mass in kilograms multiplied by 9.81, which is the force of gravity. So if we put that together to find the work done, it will be 800, because 1 litre of water equals 1 kilogram. So there's 800 kilograms of water times 9.81, which is the force of gravity, times by the distance that it's going to raise up by. So if we do that as a calculation, so that's 800 times 9.81 times 30, which is the distance, that gives us 235,440. Now that is either Newton meters per minute, because it's a force, or joules, so it can be which is energy, and we're going to use joules. Okay, so we now know the joules that we have, or Newton meters per minute, 235,440 joules, that's what we're going to work with. We want to find the power, so the average power is what we're going to work out, is watts is equal to joules divided by seconds. So putting that number in, 235,440 divided by the time taken. Okay, so that's 800 litres per minute, so that is 60. And if we put that into our calculator, 35440 divided by 60. That gives us 3924, and that's watts. Now that's assuming it's 100% efficient. Okay, so we're rounding up, then we have the joules, the energy, the watts. This is the output power. Okay, so if it was 100% efficient, that would be the size of motor that you would require. So the chances are it'd be a 4 kilowatt motor. But we've got it 60% efficient. So we need to, from our formula, efficiency equals output over input multiplied by 100. We need to rearrange this to find out what our input power will be. So the input power is equal to the output divided by the efficiency, which we've already divided by 100, so that divided by 100 is 0.6. So divided by the efficiency, if we put that figure in, so we do 3924 divided by 0.6. If you do that's a calculation, so that's 6540. So our motor would require basically a 6.5 kilowatt or the next size up to work this. Okay, so here we have another question. 80% efficient pump with an output power of 50 kilowatt raises 3,000 litres of water, a distance of 60 metres. Calculate the time taken. So this we have to work backwards. So we know the output power and we know it's 80% efficient, so we can find the input power. So efficiency equals output over input. So this time we know the output, we want to know what the input is, so rearrange. So that becomes 50,000 divided by 0.8, and this will find our input power. So that gives us 62,500 watts. So that's what the motor would have to be rated at. What we can now do is find the joules. So how much energy is it going to take? Which is force times distance. So we know that force is the amount of kilograms multiplied by 9.81. That's our force, times the distance, and we know that is 60. So if we put those figures in, so 1 litre of water equals 1 kilogram, so that's 3,000 times 9.81 times 60. And it's another big number, but it's 17658, and that's joules. So 1.7 million joules of energy required to lift that. So we know that the watts is equal to joules divided by time in seconds, and that's the bit we're after. So we need to rearrange this as a formula. So this goes up there, becomes a multiply, that comes back down, becomes a divide. So time in seconds equals joules divided by watts. So we can put that in then, so that's 17658 too many, divided by doing the calculation. So here's that divided by 62500. So 28.25 seconds. So there we have the same question, similar to what we had a minute ago, but working backwards this time.